Welcome to Docker and Kubernetes, Zero to Production, a 15-part series that takes you from complete basics to running real workloads in production. In this first episode, we're answering the most fundamental question: what actually is a container, and why does Docker matter? Every developer has heard this sentence: it works on my machine. An application depends on a specific operating system, specific library versions, specific configuration. Move that code to a different machine, and something is almost always different enough to break it. Before containers, teams solved this with detailed setup documents or by hand configuring every single server. Slow, inconsistent, and painful to repeat. Virtual machines were the first big answer to this problem. Each virtual machine runs its own complete operating system on top of a hypervisor, which makes it heavy, often gigabytes in size, and slow to start, sometimes taking minutes. Containers take a different approach. Instead of virtualizing an entire operating system, containers share the host machine's kernel and isolate just the application and its dependencies. That makes them dramatically lighter, often just megabytes, and they start in a second or less. Docker is the platform that made containers practical and popular. It gives you the tools to package an application together with everything it needs to run: code, runtime, system libraries, configuration, into a single unit called a container image. That image runs exactly the same way on your laptop, on a colleague's machine, or in the cloud. Docker launched in 2013 and has become the de facto standard for containerization ever since. Before we go further, for terms you'll hear constantly, an image is a read-only blueprint. Think of it like a class in programming. A container is a running instance of that image, like an object created from that class. A Docker file is a simple text file with step-by-step instructions for building an image. And a registry, like Docker Hub, is where images are stored and shared, so you can push an image up and pull it down on any other machine. Here's a simple mental model to hold on to. You write your application code and create a Docker file describing how to package it. Running Docker build turns that into an image. Running Docker run turns that image into a live, running container. Push that image to a registry, and any other machine with Docker installed can pull it down and run the exact same container, byte for byte identical to the one on your machine. Under the hood, Docker uses a client-server model. When you type a Docker command in your terminal, that's the Docker client. The client sends your request over a REST API to the Docker daemon, a background process called dockered, which does the real work: building images, starting containers, managing networks and storage. The daemon can run on your local machine or on a completely different server, which is part of what makes Docker so flexible. So why did this change the industry? Consistency, because the environment you test in is the exact same environment that runs in production. Speed, because containers start almost instantly compared to virtual machines. Efficiency, because you can run far more containers than virtual machines on the same hardware, since they share the underlying kernel. And portability, build a container image once and run it on any machine that has Docker installed anywhere in the world. This is just the beginning. In Episode 2, we'll install Docker and run your very first container. Episode 3, we'll write your first Docker file from scratch. Over the following episodes, we'll cover images, volumes, networking, and Docker Compose for multi-container applications. And starting around Episode 8, we move into Kubernetes, the system that orchestrates containers at scale, taking you all the way to production-ready deployments by Episode 15. That's it for Episode 1. Now you know what a container is, why Docker exists, and the core vocabulary you'll need for the rest of this series. Subscribe so you don't miss Episode 2, where we install Docker and launch our first container. See you then.